In this video, we're going to redefine what the word spontaneous means specifically in regards to electrochemistry. So when reactions are defined as being spontaneous, that means that they generally happen automatically. In previous units, we looked at how spontaneity is directly related to activation energy, but in this video, we're going to focus specifically on the concept of electrochemical spontaneity. And in order to do that, we need to talk about what electrochemical potential, also known as voltage, is. Now, for the people with a strong physics background, we're going to get a little bit simplified here. For now, in chemistry, the term voltage refers to the potential, meaning the capability for electron movement, because all electricity is based on the flow of electrons. So electrical potential or electrochemical potential is the capability for electron movement between 2 points. So in future episodes, when we learn about the structure of an electrochemical system, we'll learn that the origins of electricity are what we call electrodes, and the movement of one electrode to the other, if this is done more easily, then it has a higher electrochemical potential and therefore a higher voltage. Now, this movement of electrons, the flow of electricity from one electrode to another electrode, represents the capability for an electrical system to do work where the flow of electrons can be used to power an electrical device, such as something simple as a light bulb, all the way up to your phone or your personal computer. Now, in order to understand that, we need to look at a table of electrochemical potentials. Now, we can see that this electrochemical potential table only lists voltages for reduction reactions, and we can see that these are reduction reactions because every one of these reactions involves a compound or element gaining electrons. So because these are only reduction reactions that are showed, the compounds that are listed in terms of their electrochemical potential are listed only by their strengths as oxidizing agents. Now remember, an oxidizing agent pulls electrons away from another compound, and therefore the oxidizing agent is reduced. And not surprisingly, if we look all the way at the top of this table, we see the strongest oxidizing agent is fluorine, which is absolutely no surprise because fluorine is the compound that most easily gains electrons because it has the highest known electronegativity. Now, in terms of connecting voltage and electrochemical potential to the concept of spontaneity, it's relatively simple. Whenever we have a voltage that is positive, the reaction is defined as being spontaneous. If you want to look at this in a more practical way, any half reaction that has a positive voltage is a half reaction that produces electricity, and because the reaction releases electricity or is able to do work with the electron flow, it is defined as being spontaneous, while any half reaction that has a negative voltage is defined as requiring electricity in order to function. In other words, if we look at all of these non-spontaneous reduction reactions, because these reactions do not generate electricity when they occur, we need to actually add an artificial source of electrons in order to get these reactions to happen at all. Now, one of the problems in terms of calculating electrical potential is we only have the electrical potentials listed for the oxidizing agents or for the reduction reactions. So how do we flip these reactions around? Well, to do this, all that we do is we take the electrochemical potential, which again is the voltage of the reduction half reaction, and simply reverse it in order to find the reduction potential of the oxidation reaction. So if we want to look up the oxidation potential of magnesium, for example, we need to go to our data table and find what the reduction potential is. So the reduction potential of Mg2 plus is negative 2.37 volts. Well, let's write that in there. And all that we need to do in order to find the oxidation potential, that being the potential for magnesium to lose electrons, is take the reduction potential and reverse the sign. So the oxidation potential of magnesium metal would simply be positive 2.37 volts. In the next video, we're going to look at how to combine the reduction potential of the oxidizing agent and the oxidation potential of the reducing agent in order to calculate the overall voltage of a complete redox reaction.